Whenever you're at a concert or a big game and you're just staring at one of those absolutely massive LED screens, have you ever just stopped and wondered, how in the world did they even get that up there? It's not just a TV, it's like a building made of light hanging in the air. Well, that's what we're going to get into, peeling back the curtain on the incredible invisible layers of safety that make it all possible. So, what does it really take? How do you build something that's part skyscraper, part power station, and part supercomputer, all while it's hanging high above thousands of people? Well, the answer isn't just one simple thing. It's a really deep, systematic approach, a set of protective layers, each one just as critical as the next. All right, let's start with layer one, the physical foundation. This is the stuff you can actually see and touch. We're talking about the raw strength of it all, the steel, the rigging, and the crucial gear that holds the screen up and, way more importantly, protects the people putting it together. Now, you might think it's the Wild West up there on those rigs, but it's not. There is a very specific rule book for this kind of high-stakes work. In the US, it's called the ANSI/ASSP Z359 Fall Protection Code. You can basically think of it as the Bible for working at heights. It covers everything, from how a safety harness has to be made to the exact steps for a rescue mission. So what does that rulebook look like in the real world? Well, it's so much more than just clipping on a safety line. It creates this entire ecosystem of safety. You've got properly built scaffolding with guardrails, anti-slip platforms, and this one is huge, relentless inspections of every single cable and bolt. The structure itself even has to be engineered to stand up to high winds, following super strict international standards. Every single piece is a vital link in the safety chain. And here is a number that is absolutely burned into the brain of every single installer. The structure holding that screen, the wall, the frame, you name it, it has to be strong enough to support a minimum of 4 times the screen's actual weight. And that's not a suggestion, it is an ironclad rule. It's a safety margin that is specifically designed to make a catastrophic failure pretty much impossible. Okay, so the structure is solid. Now let's talk about the invisible force that brings it all to life: electricity. We're moving to our second layer, taming the current. This is all about managing the insane amount of power these screens consume and dealing with the very real dangers that come along with it. To work with that kind of power, technicians rely on a life-saving protocol called lockout/tagouts, or LOTO for short. And the idea behind it is just brilliant in its simplicity. When a system needs work, it gets physically locked in the off position. This makes it literally impossible for someone else to accidentally power it back up while you're working. And LOTO isn't just flipping a switch. It's a very strict 6-step process. First, you prepare, identifying every single place the energy could be coming from. Then, you shut down and completely isolate the equipment from its power source. After that, you apply the physical lock and tag. And here's a super important step. You check for any stored energy, like in a capacitor. And only after all of that do you finally verify that the system is 100% dead before you start your work. You see, that little tag, it's more than just a piece of plastic. It is a personal shield. When a technician puts their own lock and their own tag on that circuit, it's screaming hands off to everybody else on the site. It's a clear visual statement that says a life is on the line here, and messing with this could be fatal. Of course, all of these on-the-ground procedures are backed up by some serious international standards. You've got codes like IEC 6364 that make sure everything is grounded and insulated correctly, and IEEE standards that lay out the best way to power sensitive electronics. These aren't just suggestions. They are the engineering backbone for every safe electrical install. All right, let's move on to our third layer, managing the environment. Because you can have the best gear in the world, but safety is also about understanding the unique and often dangerous spaces where the work has to happen. I want you to just picture the areas behind or underneath one of these giant screens. Technicians are often working in these really tight control rooms or dark service tunnels. These are definitely not your typical offices. They are classified as confined spaces, and they can have all sorts of hidden dangers. So what makes a space so hazardous that you actually need a permit to go inside? Well, according to OSHA, it's a few key things. We're talking about a dangerous atmosphere, maybe a lack of oxygen, or the risk of being literally buried by something. It could even be a weird shape that might trap a worker. There is a very, very good reason why entry into these places is so tightly controlled. So how do crews deal with these risks out on a job? It's all about practical steps. They set up clear exclusion zones, basically no-go areas for anyone not involved in the overhead work. They are constantly monitoring the air and using powerful ventilation systems in those tight spots. And if they're in a public venue, it means putting up safety nets and barriers to keep the public completely separate from the work zone. And that brings us to our fourth and final layer, the brains of the operation. Now we're going to look inside the technology itself, at the screen's components, to see how they're engineered from the ground up to prevent the single biggest technological threat: fire. Fires in these huge electronic systems almost never just happen. They're pretty much always caused by things that are totally preventable. Things like an electrical overload, a short circuit from cheap or faulty wiring, or, and this is a big one, heat building up because of poor ventilation, or even just dust acting like a thick, warm blanket on the components. But here's the good news. For every single one of those risks, there is a direct engineered solution. You can think of it like a planned defense system. That risk of electrical overload, stopped cold by surge protectors and circuit breakers. Worried about heat buildup? That's managed by smart ventilation designs and thermal sensors. Short circuits? That risk is minimized by only using high-quality, certified parts and wiring. Even the raw materials used to build the screen are part of the fire defense plan. Safety codes like NFPA 70E demand that the screen's frame and panels have to be made from materials that either won't burn at all or are certified to be highly resistant to the spread of flames. Fire safety's literally built right into the screen's DNA. So as you can see, safety on this scale is never about just one thing. It's the structural strength, it's the disciplined electrical work, it's total awareness of the site, and it's fire-resistant technology. These 4 layers don't exist on their own. They all weave together to form one single integrated system designed to protect everyone: the crew, the public, and the hardware itself. And that really brings us to the final question. The next time you find yourself at a show, staring up at one of those incredible screens, will you see just the brilliant pixels? Or will you now see the hidden layers of engineering, the strict protocols, and the careful planning, all that invisible work that ensures the only thing you have to worry about is enjoying the show?